Hello everyone and welcome to this tutorial session. In today's tutorial, we want to find the solution set, the real values of x that satisfies the following inequalities. The first one, x all over x minus 2 greater than or equal to 1 all over x plus 1. And then question B, the absolute value of the function 3x plus 4 all over 2x minus 3 less than 1. We want to get all the real values of x that will satisfy those inequalities. All right, so please follow the solution from the beginning to the end. There are lots of insight that you are going to learn. Okay, let's start. The first question is the inequality x all over x minus 2 greater than or equal to 1 all over x plus 1. We see this is a rational expression, this is another rational expression. Okay, we have the unknown at the numerator and the unknown at the denominator, so we are advised not to carry out cross multiplication. We are not allowed to carry out cross multiplication in inequalities of this nature because we don't know the value of the unknown x here. Remember, with inequality, if you have this expression and if you multiply both sides by the negative sign, if I come here and multiply here by the negative sign, automatically this inequality sign will reverse to this and also multiply that. So because we don't know the sign of x at the denominators here, we avoid that situation where we could get an erroneous solution trying to cross multiply. Okay, so cross multiplication here is not allowed. But if we were equations, on the other hand, if this were an equation that we had an equal sign here, okay, here we can carry out cross multiplication. Okay, we can carry out cross multiplication. Here, cross multiplication is allowed because we don't have any risk of missing out on any solution. All right, so we are doing inequalities. Cross multiplication is not allowed. So what do we need to do? All we need to do first is to take this quantity from the right hand side to the left hand side, or if you wish, you take this one of the left hand side to the right hand side in order to obtain a 0 on one of the sides. All right, so let's take this one, 1 all over x plus 1 from the right hand side to the left hand side. And so we're going to obtain x all over x minus 2. Taking all of this, remember the sign here is positive, it becomes minus x plus 1 greater than or equal to 0. So we obtain a 0 now on one side. So let's bring this to a common denominator. The LCM should be their product. This multiplied to that, x minus 2, x plus 1. Okay, this is the LCM. This LCM divided by x minus 2. X minus 2 will cancel and we're left with x plus 1. Multiply to x. So write x into x plus 1 minus this LCM divided by x plus 1. X plus 1 will cancel x plus 1. We're left with x minus 2. All right, so multiply to 1, we'll have x minus 2 greater than or equal to 0. This parenthesis here is very, very important. If we don't put this parenthesis here, this one we might omit. No, we can't even omit one because we have to multiply also by x. If we don't put this parenthesis here, for example, someone does that, you will see that this subtraction will affect, this minus sign will affect only x and it will not affect the negative 2. But this minus sign was supposed to distribute itself into x minus 2. So you must put this parenthesis. Very, very important. Okay. Now, let's open the parenthesis. X multiplied to x is x squared. X multiplied to 1 is x. Negative multiplied to x, negative x. Negative multiplied to negative 2, positive 2. All over x minus 2, x plus 1, greater than or equal to 0. Okay, this gives us x squared. x minus x, this quantity is 0. X minus x is 0. So we're left with plus 2. So I have x squared plus 2 all over x minus 2 into x plus 1 greater than or equal to 0. This is what we have. So we've gotten at this point. From here, the next thing to do is to get our critical points. Our critical points are those values of the variable that can render either the numerator 0 or the denominator 0. If we look at the numerator here, we see there is no value of x that will render that numerator 0. No value at all. If we try to check, we will put x squared plus 2 equals to 0. Then we're going to obtain x squared equals to negative 2. And so if we take the square root of both sides, we're going to have x equals root of negative 2, which is not a real number. Remember, we're asked to find all real solutions. All right, all real solutions. We want to work on the set of real numbers. So the numerator will be left alone. We'll now go to the denominators. What are the values that can render x minus 2 0? That critical value is 2. We also set x plus 1 to 0. The next critical value is negative 1. Now we go on our number line and we put those values on the number line and we find our solution set. Negative 1 is smaller than 2. So we have 1, 2, 3 zones to test values from. Let's take a value from here and test in our inequality. This is our inequality. So remember, the numerator has no major role to play here, because for all values of x, that numerator will always be positive. So we'll concentrate on the denominators. So we have x minus 2, x plus 1. We're interested in the sign. Let's take a value from this zone. Any value to the left of negative 1, for example, negative 2. Negative 2 is this way. Okay, so it belongs to this zone. Put it there. Negative 2 minus 2 is negative. And then negative 2 plus 1 is negative. Negative multiplied to negative, positive. Let's enter into this zone. A good value could be 0. So let's take x to be 0. All right? Let's take x to be 0. We're interested only in the signs. 0 minus 2 is negative. 0 plus 1 is positive. Negative times positive, negative. Let's take a value in this zone. For example, positive 3. We'll take positive 3. 3 minus 2, positive. 3 plus 1, positive. Positive multiplied to positive, positive. Okay, so this analysis gives us these signs. So which of these zones will constitute our solution set? We come back here, we look at our inequality. It says greater than or equal to 0. Remember, greater than or equal to 0 or greater than 0 simply means positive, and less than 0 means negative. Okay, so greater than 0 means we'll get the zones where we have positive. We have positive here, we have positive here. So our solution will lie either to the left of negative 1 or to the right of positive 2. Now, pay attention. Solution set. Now, don't make the following error, to come and say our solution set will be all real values of x such that x, okay, we want to follow the inequality sign, less than or equal to negative 1, or x greater than or equal to 2. This is erroneous. It's going to, this solution set is not correct. Okay, so please pay attention. Why is it not correct? If we say x should be less than or equal to negative 1, it means there is possibility of equality. That means x can become negative 1. But if we look at our expressions, you see that if x is negative 1, then our inequality will become undefined. Also, on the right hand side, x greater than or equal to 2. It means there's a possibility of x being equal to 2. So if x is equal to 2, the left hand side of our inequality will become undefined. So to be on the safe side, all we need do is to take away the equality, the possibility of equality. And so this gives us now the correct solution set for the first inequality. Okay, now let's take the second inequality. Our second inequality says we should look for the solution set of absolute 3x plus 4 all over 2x minus 3 less than 1. We want to find the solution set of this inequality. Now, we remember the property, we have to use the property of inequality, which says absolute x less than 1 is the same thing as saying minus 1 less than x less than 1. Okay, so we're going to work with this property. Okay, so we have the absolute here and then less than 1 there. So our inequality will become minus 1 when we follow this, less than 3x plus 4 all over 2x minus 3 less than 1. This is the inequality that we have to solve now. Inequalities of this nature is best done when we split the inequality into two. All right, this middle member will go with this left-hand member. The same middle member will go with the right-hand member, and then we intersect our solution set to bring out the unique solution set. And so this will be negative 1 less than 3x plus 4 all over 2x minus 3 intersection the same middle member 3x plus 4 all over 2x minus 3 less than 1. We'll get the solution set of this inequality and we'll intersect the solution set with the solution set of this other inequality. Let's start with this one. Again, we have a rational inequality here. We cannot carry out cross multiplication. It's not allowed because we don't know the value of the unknown x. So to be on the safe side, we'll make a 0 on one of the sides. So we'll just take this negative 1 from the left hand side to the right hand side. It becomes positive 1 and then we'll end up with 0 here. 3x plus 4 all over 2x minus 3. This negative 1 coming over there becomes positive 1. Okay, so let's first of all finish with this one. Later on, we'll take this other one and then we'll intersect our solution. So we handle this to bring this to a common denominator. To bring this to a common denominator, we'll also write 1 as a fraction. We can write 1 as 1 all over 1. So we have 0 less than 3x plus 4 all over 2x minus 3 plus 1 all over 1. The LCM here is 2x minus 3. When we take this and multiply to 1, okay, that gives us the LCM. So 2x minus 3 divided by itself is 1. Multiplied by the numerator, we have 3x plus 4. 2x minus 3 divided by 1 is 2x minus 3 multiplied to 1. So we have 2x minus 3. So we have 0 less than 3x plus 2x, 5x, 4 minus 3, 1, all over 2x minus 3. Okay, this is a new rational inequality that we obtain. If 0 is less than this, we want to read it the other way around, we can write it as 5x plus 1 all over 2x minus 3, this time around greater than 0. Okay, now we get our critical points. Critical points. Critical points, those values that can render the numerator 0. What are the values? We have x is equal to negative 1/5. Okay, the value x equals negative 1/5 will render the numerator 0. What are those values that will render the denominator 0? So we divide both sides by 2. We have x is equal to 2/3. Okay, 3 all on 2, sorry, not to third. So this is our next critical value. The next critical value is x equals 3 all over 2. Okay, so having gotten our two critical values, let us now use our number line to carry out our analysis. Let's use our number line to carry out our analysis. We'll put those values on the number line. Negative 1/5 is to the left, and 3 on 2 to the right. So we also have three zones to test: this zone, this zone, this zone. All right. Where are we testing? We are testing on this expression, okay, which is written in a better form. Okay, we're testing on this expression. Okay, let's start with this zone. Take a value in this zone. A good value in this zone, this is negative 1/5. So you can see that negative 1 is in this zone. All right, so we can take x equals negative 1 and we'll put there. We're going to obtain negative 5. So I just put negative 5 there. Negative 5 plus 1 all over negative 2 minus 3. Negative 5 plus 1 is negative, divided by negative 2 minus 3 is negative. So we have negative divided by negative, positive. So here we have positive. Coming to this zone, this is negative 1/5, 3 on 2, 0 is in between. So 0 is a member of this zone. So if we put 0 there, we're going to have 5 multiplied to 0 is 0. 2 multiplied to 0 is 0. And so we obtain positive divided by negative. Positive divided by negative, which is negative. Take a value in this zone. This is 3 all over 2, which is 1.5. So 2 and above. Any value up, from 2 and above is acceptable. So if we take, for example, 2 and we put here 5 multiplied to 2 is 10. 2 multiplied to 2 is 4. 10 plus 1 positive. 4 minus 3 positive. Positive divided by positive, positive. So this zone here is positive. Okay, so which of the three zones is going to give our solution? Which of the three zones is going to give our solution? We'll see again that here we have greater than 0. Greater than 0 means positive. So our solution lies here or here. Okay, so the first solution set is all values of x strictly to the left of negative 1/5, or all values of x strictly to the right of 3 all on 2. That gives us our first solution set. Okay, the solution set of that first inequality. Okay, now let's take the second inequality. The second inequality was, so we say also, the second inequality was 3x plus 4 all over 2x minus 3 less than 1. Okay, now again, we can't carry out cross multiplication, is not allowed. So we take this one from the right hand side to the left hand side. That gives us 3x plus 4 all over 2x minus 3 minus 1 less than 0. We should obtain 0 on one of the sides. Now, we can also write this as a fraction, and then we'll carry out the same algebraic simplification to obtain a single fraction. So the LCM of this and this is just their product, which is 2x minus 3. 2x minus 3 divided by itself is 1. 1 multiplied to 3x plus 4, we have 3x plus 4. 2x minus 3 divided by 1 is 2x minus 3 multiplied to negative 1. So we have negative into, we must use this parenthesis, 2x minus 3 less than 0. Okay, so we open the parenthesis. We open the parenthesis, we have 3x plus 4 Negative times 2x is negative 2x. Negative times positive 3 becomes positive 3. No, negative times negative 3 becomes positive 3, sorry. So all over 2x minus 3 less than 0. 3x minus 2x is just 1x. 4 plus 3 is 7. 2x minus 3 less than 0. So this is the new rational inequality that we obtain now. So we also look for the critical points. The critical points that will render the numerator 0 is just the point x equals negative 7. The critical point that will render the denominator 0 is simply the value x equals 3 all over 2. So we have critical points negative 7 and 3 all over 2. Let's do his own analysis on the number line. All right, so we have negative 7, 3 all over 2. We have 3 zones also to verify. Take a value from this zone. For example, it's going to be negative 8. We're going to be working with that. So we're interested in the sign. So we have negative 8 plus 7 all over 2 multiplied to negative 8 minus 3. We're interested only in the sign. So negative 8 plus 7 is negative divided by, this is 2 multiplied to negative 8 is negative 16 minus 3 is negative. Negative divided by negative, positive. We're interested only in the sign. Now let's take a value in this zone. Again, 0 is very, very good. It's the best. So 0, 0. So here we'll have 0. Here we'll have 0. So we're going to obtain positive up and negative down. Positive divided by negative, negative. Take a value in this zone, 2. All right. 2 is found in this zone. We put it there. 2 plus 7. 2 multiplied to 2 is 4. So 2 plus 7, positive. 4 minus 3, positive. Positive divided by positive, positive. So which of the 3 zones gives us our solution set? Pay attention, we have here less than 0, so negative. So this is a zone that will give us our solution set. So here we have the solution here. Our solution here will be all real x such that negative 7 less than x less than 3 all on 2. Okay, that's the solution set. Now remember, we have to intersect this solution and this solution to get our unique solution for the inequality, the absolute inequality that was given us. How do we get that intersection? Let's walk this way. To see it much clearer, let us use a unique number line. Let's use a unique number line where we're going to put in all the critical points that will have in our solutions. Negative half, 3 all over 2, and negative 7. So here the smallest is negative 7. Here we'll have negative half, and then here we'll have 3 all over 2. Okay. What do we see here? There's no negative half, it's negative 1/5. Oh, sorry, negative 1/5. X less than negative 1/5 or x greater than 3 all over 2. So it's negative 1/5. So we have this. Let's first of all represent this solution. This solution again, we see where we have our tick. Everything to the left of negative. So negative 1/5. That's that solution. And to the right of 3 all over 2. That's that solution. Now, this solution, this is it. Now let's represent this other solution also there. Now here, our solution says from -7 to 3 all over 2. If we can take it a little up, -7, then 3 all over 2. This is this second solution. So where do we have intersection? Okay, intersection means a solution zone that falls in both solution sets. Okay, you see values here will fall only in our second solution, but they will not fall in our first solution. Values here will fall only in our second solution there, but will not fall in our first solution. Values here falls only in, again, our second solution, but they don't fall in our first solution, except these values. If you look very carefully, this shaded zone gives us values that are found in both solution sets. Any value from -7, that's any value from -7 to -1/5, falls in both solutions. And so our solution set now, our final solution set for our inequality will be all real values of x such that -7 less than x less than -1/5. This is our final solution to the inequality, the absolute value inequality.